Hello everyone and welcome to the new session of electricity. So electricity that we are going to start today is very important for class 10 physics. So this chapter is included in ICSE as well as CBSE. And if you are reading from a state board, it is also included in your state syllabus. So this chapter is very important from any aspect or any point of view. So without any delay, let's start the session. So whenever I use the word electricity, what is the first thing that comes in your mind? Yes, a glowing bulb, moving fan, and the things that work on electricity. That's not electricity. They are the things that actually work on electricity. So without any delay, we are going to start our session. So today is our first lecture and we are going to introduce electric charges, conductors, insulators and electric current. Because the name of the chapter is electric current. So that thing is by default we're going to start in our first session. We'll elaborate the thing in our next session, but let's start it. So here, the first question anybody can ask, like, what is the basic properties of a matter? In class 6, you must have read anything that occupies space and has mass is called a matter. So that is the first basic property. So why we are going to ask this? Because as you know that current, it is a fundamental part of the movement of charges. Okay, so that is the thing. And where does the charge come from? To give you the complete idea, we have started with the basic fundamental properties of matter. So the first thing, it is a definition of a matter, and you know what is it? A matter is anything that occupies space and has some mass. So it has mass, as you can see, and it occupies space. The first thing. Next, it has charges inside it. Charges? Do you remember? Have you ever studied it as charge? Yes, in class 9th, we have studied that atom consists of electrons, protons and neutrons. While electrons are negatively charged, protons are positively charged and neutrons are neutral. So we can say electrons and protons. So electrons are negatively charged, so I wrote it as E negative, and protons are positively charged. That's the reason why I wrote it as E positive. Next, what is the smallest unit of matter? The smallest unit of matter is, what is matter made up of? A matter is made up of atoms, and these atoms combine together to make up a matter. Remember that? So let us take an example. So the answer will be here. But what example can we take? We can take the example of a matter. As you can see, right? That is a sodium atom. And you must have read about electron dot structure. So the atomic number of sodium, that is in shortcut we represent it as Z, is equal to 11. So the first cell is going to have 2 electrons, the next cell 8 electrons, and the last cell will have 1 electron. So it is in the pattern of 2, 8 and 1. So that is the reason why we call it sodium. As you can see, in the last cell, it has got only 1 electron. That means this electron is free to move. Valency, this comes from this particular word, right? Valency. So in order, this sodium, in order to attain stability, what it has to do? Either it has to lose out 1 electron or it has to gain 7 electrons. Now, it is very simple. If I ask you, what would be easier, losing out 1 electron or gaining 7 electrons? So you're definitely going to say, so losing out 1 electron. So as sodium loses an electron, it becomes positively charged. As sodium is going to lose out electron, it is going to become positively charged. So this thing we'll discuss in detail. But for now, what is the valency of sodium? It is Na plus. You have heard this word. It is Na plus. So this plus means sodium has got 1 positive charge. Let us move to the next part where we can see the types of charges. So one is the positive charge, while the another one is negatively charged. So positive charge is developed on protons and the negative charge is developed on what? Electrons, right? electrons. So negative charge develop on electrons and positive charge develop on protons. So we have some properties related to that. What is the property? That unlike charges attract, unlike charges attract, while like charges, you can see here, they are repellent. So that is the property of charge. Very important, that should be inside your head every time. Like charges repel and unlike charges attract. So that is the property. Let's move to the next part, where we have, when do we say that a body is negatively charged? Body is negatively charged. So if I go back here and I ask, the sodium was positively charged, what was the reason? So now you can tell me that sodium has lost an electron. That is the reason why it is positively charged. And here the question is, when do we say a body is negatively charged? Just opposite. It can be a body is negatively charged only and only if it gains electron. Only and only if it gains electron. So I can write it here. When a body, or here in shortcut, sometimes we are going to use the word atom, gains electron, it gets negatively charged. Now, when do we say a body is positively charged? So, when a body loses electron, when a body loses electron, that time we can say that the object or the body is positively charged. And when do we say a body is neutral? So that is very important question. So in the entire world, if we have a matter, it will always contain charge. It is never like that. It is not going to contain charge. It is always and always contain charge. Always. You cannot say that it is not containing charge. It will definitely always contain charge. So if it is always containing charge, then how a body becomes neutral or no charge? So when we say no charge or neutral, that means the object or the body is containing equal number of positive and negative charges. What we can say? That the object or the body is containing equal number of positive and the negative charges. So this is the condition when we can say a body is neutral. Means it is not having any charge. Not having any charge means the quantity of positive and the quantity of negative charge are equal. So then, how does the body get charged? Very important question. So you must have done an experiment. You must have taken a plastic scale, rubbed it in your hair and bought it near small bits of paper. And small bits of paper got attracted. You must have done that. Now, if they got attracted, what was the reason? That the scale, the plastic scale that we have rubbed it in our hair. So when we do friction, what we say that yes, it has got charge. So the very important thing, we can charge an object by friction. So friction is a method through which we can charge an object. Okay. So here's an example. I gave you an example of plastic scale, but in the image that is the comb. So that is also plastic, right? The comb is also made up of plastic. So yes, here again we can see the same scenario. You must have seen when you come near to the screen of a television, or hair gets attracted toward it, right? So that is an example of charge object. That is also an example. Now, the very important thing, what is a charge? So charge is an additional property of an atom to gain or lose electron. So again, a charge is denoted by Q. That is very important again. Every time anybody is going to represent a charge, it will be denoted by the word Q. Next, the SI unit of charge is Coulomb. So Coulomb was the scientist who has discovered this charge, that electron contains charge. That's the reason why we have used his name. And when you go to class 12, not right now, in class 12, you will get a formula, Coulomb's law, where separate the property like charges repel and unlike charges attract. So what is the force of attraction or what is the force of repulsion? So that thing we are going to study here. Now, quantization of charge, that is actually very important. IMP, that is very important. You remember right now I said that if sodium Na has lost one electron, so we write Na plus. Sometimes we write Ca2 plus. So what does this 1 plus, 2 plus, 3 plus means? That means it has lost one electron, it has lost two electrons, right? So like this, if we get aluminium, it will lose 3 electrons. So it goes on like that, losing the number of electrons. So if it is losing number of electrons, we can say that charge is equal to number of electrons. So we use a particular word for that, and that word is quantization of charge. So what is this quantization of charge? That the total charge is always an integral multiple of number of electrons. Okay, so that is the definition. But what is the formula? Formula is Q is equal to plus and minus. It can be positive charge, it can be negative charge. Plus or minus Ne, where N belongs to a natural number. N is equal to natural number, because you cannot break an electron more smaller than that. That's not possible. So minimum 1 electron, then 2 electron, then 3 electron, then 4 electron. Like this, the charges will be developed on an object. Now, then what is electric current? Electric current, it is very simple. You can see that what it is. It is a battery. So in first case, the switch is on and the circuit is complete. While in the second case, the switch is off and the circuit is not complete. So when the circuit is complete, you can say that the lamp is glowing. It is a closed circuit. We call it closed circuit. While this one we are going to call it open circuit. In this case, the lamp, it is not glowing. No, it is not glowing. So why it is not glowing? Because the current that is moving from one end to the another end, from here to this particular side, what is happening with it, like at this particular junction, hold a second. Yeah, so at this particular junction, it is getting no way to move to the other side. So if it is getting no way to move to the other side, so in this particular case, electron does not flow through the filament of a bulb and the bulb does not glow. But in this case, here the switch is on, electrons can easily move, and then we can say yes, the bulb is glowing. So that is the difference. Now, so here electric current, it is the rate of flow of charges. So we'll discuss about the formula also, don't worry. But in which object current can flow? Conductors. In which object current cannot flow? Insulators. To be very honest, if you remember, like some object they were able to donate electrons, while some of them what? Received it from the donor, right? Like sodium, it was donating an electron, while chlorine, it was taking an electron. So if you remember the formula of NaCl, we write it as Na plus Cl minus. That means sodium is losing one electron and chlorine is gaining an electron. That is the reason. So as sodium was losing, it got positively charged, and as chlorine was receiving it, gaining it, it got negatively charged. So here the number of electron was 1 less than the number of proton, while in chlorine the number of electron was 1 more than the number of proton. That's the reason why we write it like this. Now, what is conductors and insulators? So conductors are the objects through which current can pass easily. So here are some examples. So this example, first you can see the wire that we use, it is made up of conductors. Why it is made up of conductors? So that current can flow easily. And the examples will be copper wire, aluminium, silver, gold, iron, and even me. Because we have iron in our blood, so because we have iron, that is a metal, we can say that current can flow through us, but not with very high potential, very low. Because the resistance will be high, we'll get a shock. Fine. So these are the conductors. So go right now and comment what is the best conductor. Till then, I'll move forward. So what are the examples of a non-conductor? Rubber. We use sleeper while operating electrical appliances or making or repairing of electrical wires. Plastics, wood, dry. That is very important. No, not wood. Use the word dry. That will be far better than using the word wood. Then we have cotton, glass, and that's it. So now conductors. What is the definition of conductor? An object that allows electricity to pass through them. To pass through it is called conductors. Again, you can see an example. So this is the wire from where you can see the negatively charged objects are moving from one end to the other end. So these negatively charged objects are electrons and they are moving from negative direction towards the positive direction. So what we can say that current, if it is flowing in this direction, electrons will be flowing in the opposite direction. So here that is very important that the charges or the electron always flow in the direction opposite to the flow of current. Now you can see it here, we got copper. So in copper, what you can see at last, we got one free electron. Hey, it is not stopping. Fine, it is moving ahead. So that's not okay. So it has got one electron because its atomic number is 29. So 2, 8, 18, and 1. We know how the atoms are, how the electrons are arranged in the formula of 2n square. So according to that, we got this particular part. So path of electrons inside a conductor. Again, that is important. Right now, what I told, electrons flow opposite to the direction of flow of current because they are negatively charged. So see here, from negative, they are starting from here. That's the negative part. From here it is starting and then it is moving towards the positive part. So this is how electrons flow, and current, it moves from positive to negative. So because electrons are negatively charged, they will start from negative terminal and move towards the positive terminal. Because we know unlike charges attract and like charges repel. So that is the concept what we used here. Again, insulators. Here carbon is an example of insulator. So why carbon can be termed as insulator? Because it has got 4 electrons. So these 4 electrons are not free to move from one atom to the other. They are not free to move. And as they are not free to move, what we can say? They are insulators. In which atom the electrons are free to move, we call them conductors. Again, you can see the example, how the carbon bond we have made. So you have remembered the word plastic that we have used, plastic. So this plastic is also an example of insulator. So this plastic is made up of carbon. Plastic is made up of carbon and carbon is an insulator, you know that. Now, what is an electric current? So I just gave a definition. The rate of flow of charge is called current. So I'll write it here. Rate of flow of charge is called electric current. Okay. Now, the formula. Electric current is denoted by the formula I. Electric current is denoted by the formula I. So we have used the formula I. So it is equal to I can be written as Q by T, where Q was charge and T is time. And SI will be equal to ampere. It's shortcut. capital A because ampere was the name of a scientist, and if SI unit or the unit is based on the name of a scientist, it is written in capital letter. If it's simply like this or this, then we write it in small letter. Okay, and current is a scalar quantity. You know why current is a scalar quantity? It has magnitude, it has direction, but it does not obey Vector's law of addition. I'll write it here because it does not obey Vector's law of addition. Vector's law of addition. That is the Pythagoras theorem. In our language, till now, because of the Pythagoras theorem concept. So, what is 1 ampere of current? So, what is the formula of current? So, I was equal to Q by T. So, when what we can say 1 coulomb of charge flows per second or in 1 second, that is called 1 ampere. So that is the definition. And how many electrons produces 1 coulomb of charge? So what is the formula? Q is equal to Ne. So Q is 1 and what is the charge on an electron? That is equal to minus 1.6 into 10 to the power minus 19 coulomb. So instead of E, I can write 1.6 into 10 to the power minus 19 coulomb. So if we solve, it will become N is equal to 1 by 1.6 into 10 to the power minus 19 coulomb. That is equal to 6.25 into 10 to the power 18